Okay, Assalamualaikum. So we continue for the last part of this chapter number 9. So you see that the cell contain information. Okay, so what are the information that is stored in the cell? Some of the cell. Okay, so let's say mRNA, messenger ribonucleic acid, mRNA. Okay, that one. So information introduce an fully statistical ground as a measure of the number of choice possible when making a selection for a string of elements. Okay, so it is detail the what from one cell, from one uh, same cell. Okay, so some cell going to become lung, some cell are becoming the heart, some cell are becoming a kidney, some cell are becoming heart, uh, our brain, some cell becoming our bone. Okay, so you can see that uh, depend on the information, so the cell can adapt and becoming the cell specific for that uh, organ. Okay. Okay, so that information is fully structural aspects such as chemical entropy, interaction, and chemical entropy chain. Okay, so here we see that uh, only give the information. So how it we going to become or the instruction. So when you get the information, it will instruct the cell to become uh, the shape of the organ, to make the shape of the organ. Okay, so this instruction implies the existence of a message, a messenger, and a reader who will execute the message. Okay, so we have the message, a messenger, mRNA. These are that is uh, the messenger and the reader. Okay, so this the reader will interpret the message and execute the message. Okay. Okay, imply a message and message reader that include a command. Okay, so when the cell goes to the cell production in the organ, the in the brain, so it become a cell in the brain. Okay, so it's contain the information. So two type of information. Okay, so here we have the structural information. Simply neat and tight breaking of various molecule into macromolecule and macromolecule into organelle that comprise of the cell and also the organ. Okay, so how it going to be formed? Bentuk X ke, bentuk Y ke, bentuk Z ke? Okay, it depend on this information. And next is the functional information. Okay, so kalau bentuk Z, bentuk X, apa function dia? Bentuk Z, apa function dia? Bentuk Y, apa function? So it contains this functional information. Pertain the activity of a cell and the rate of number of chemical reaction generated. Okay, so these are DNA sequence or the information. Okay, in our DNA, the sequence. So we can see that these are the cell. Okay, imagine that we have the same cell, but because of this DNA sequence, so we can see that here. Okay, this one here and here, you can see that these are different. The rate, this region are different, so we can get honeybee, or we can produce the honeybee if this uh, message information here is in this type, and in this we can produce the bumblebee if the region or the messengers or the information here is different. Okay, so by changing this information, so we can produce the honeybee or the bumblebee. Okay, again, here we see the robin and hermite. Okay, so let me see. So here we can see that there is a small decrease in the information here, and also the small decrease in the information here. The rest are nearly the same. So we can see that we can produce two types of bird with just changing the information in the DNA sequence. Similar bar code. Salah satu je boleh jadi yang lain. Buat apa yang kita nak katakan. Sepatutnya, contohnya sel tu untuk hasilkan organ jantung, tapi sebab tersalah sequence, dan kalau dia pergi ke jantung pun dia akan jadi macam bara. Okay, dia akan hasilkan bara. Because it's not supposed to be in that organ. Okay, so the last one is the evolution theory. Okay, so when the cell becoming an organ, okay, so which one is has the higher rate to live? Okay, so we have Darwin. Okay, so we know Darwin. So Darwin idea, natural selection means that organisms with traits best suited to the environment are more likely to survive and reproduce. The factor Darwin identified that govern natural selection are, so natural selection, siapa yang kaya, contohnya macam dalam sekarang ni, siapa yang kaya boleh hidup senang, siapa yang susah akan susah, lagi susah, lagi susah, dan lagi susah. Okay, so the selection, organism produce more offspring than can survive, and therefore organism compete for limited resource. Okay, so here you can see that more offspring, but yang paling cergas saja yang akan hidup untuk dapatkan makanan. Yang boleh dapat makanan akan hidup, yang tak dapat makanan akan mati. Individual of a population vary live, and much of this variation is heritable. Okay, so macam kita ada sakit sakit apa ke, mungkin akan diwarisi ke anak. Okay, those individuals that are better suited to local conditions survive to produce other offspring. Okay, so the local condition. So kalau kita pergi ke dalam hutan, kalau kita compete dengan Tarzan, so Tarzan akan hidup lebih lama daripada kita. Okay, process for change are slow and gradual. Okay, itu bergantung pada our lifetime span. Okay. Okay, the theory of evolution. So we have Darwin and others. So for Darwin, present form of life have arisen by descent and modification from an ancestral species. And the mechanism for modification is natural selection, working continuously for long period of time. Okay, natural selection. Siapa yang buat dia hidup, siapa yang tak buat dia akan mati. Untuk yang lain, for others, evolutionary model can be developed that allows selection or elimination of given configuration independent of the presence of other configuration. Okay, so ya, sebagai contohnya, ayah miskin tapi anak mungkin boleh jadi kaya. Okay, anak dan anak kaya mungkin bapa kaya, mungkin anak akan jadi miskin. Okay, so these are the assumption of others. So here the Darwin, you can see that these are the species. Okay, so they produce a new species. Okay, the current species evolve. This one die, this one exists, hidup, dia mati, hidup, mati, hidup, mati, hidup, and this one this one will live. Okay, then the new species also. Okay, so we can see that new species also depend on which one will live and which one will die. And the other model, so here we the punctuated equilibrium model produced introduced by the Niels Aldrich and of the American Museum of Natural History, say that consists of a long period of stasis or equilibrium punctuated or interrupted by period of divergence. Okay, so maknanya new species saya boleh dihasilkan. Most species undergo most of their morphological chain when they first diverge from the parent species. After that, they change relative little even as they give rise to other species. For example, the fossil history should consist primarily of fossils from the long period of time when little or no change occurred, with only a few fossils from the period of rapid change. Okay, so here you can see that punctuated equilibrium model. So this one divergent, new species. So here we can see that. But this one dying, this one live. The new species you can see that both two branch live. Okay, and produce an of the offspring. Okay, rather than this one. Okay, so this one you can see that only the strongest will survive, even though we have a new species. Here both can survive. Okay, so the last one or the last slide. So we can do the mathematical modeling of the evolution. Okay, using mathematics and physics. So we can do, in this case you can see here the population genetic local water equation. So we see here we have type A and type B. So here type zygote type A and zygote type B. Okay, from our sperm I think. So we have type A equal to 2/3 chance of survive, and type B is half chance of survive, 0.5 of survive. Okay, so the adult, so you can see the one dying. Here is one leaf, one die, one leaf. Here, two leaf, one die. So from here, can marry this plus this become this become this become this, and if this marry with this, we have 50-50. This one and this become one. Okay, so we can do the modeling. We can calculate here weight A equal to 1, VB equal to 2, 0.6, and we can calculate the number of cell, this cell in our organ. Okay, so from that we can do the modeling of this evolution. Okay, so here we can see that from here we can have 1, 2, 3, 4, 5. This one can marry this, or associate with this to produce another one. This one again and again and again and again. Okay, so after some times or after so many generation, so how many of the new species can occur or exist in our environment. Okay, so I think we can stop here for this. So we end this lecture.